All right, let's do 22 and 23 together. We're having a business breakfast. A recent survey indicated that the average amount spent for breakfast by business managers was $7.58. Okay. So that is for the population average is $7.58. Standard deviation of 42 cents. It was felt that breakfasts on the West Coast were higher than $7.58. A sample of 81 business managers on the West Coast had an average breakfast cost of $7.65. At alpha equals 0.05, what is the critical value? So let's go through even though we're asked for the critical value, let's go through the first two steps of the hypothesis testing process. And when I say that process, I'm talking about, on your formula sheet, it has the procedure table for solving hypothesis testing problems the traditional method. So step 1, state the hypotheses and identify the claim. Step 2, find the critical values from the appropriate table. That's what we're doing in this question. 3, compute the test value. And then 4, make your decision to reject or not reject the null hypothesis, and then summarize your results. So let's do the first two steps. State the hypotheses, identify the claim, and then find our critical values. So step 1, null, alternative. So the null hypothesis is that the breakfast cost is no different than the population average. Even though I got that average of $7.65, population mean is $7.58. That's what it is. It's not anything different. The alternative hypothesis says no. I got a sample mean of $7.65. Population mean is really greater than $7.58. You got incorrect numbers there, right? Again, higher than $7.58. So this is what we're testing. 2, find the critical values. So alpha is 0.05. What's that critical value that we're going to use to determine our rejection region, right? So here, we're looking higher than. So this will be our rejection region. If our test value is actually greater than, then we reject the null hypothesis. We'll reject that. But what's that critical value that we're going to use as our start of our rejection region? So alpha's 0.05. Okay, so here's what we do. The quickest way to get there is to go to the T chart again, the T distribution again, right? So this is a one-tailed distribution. We're just talking about greater than. This is one-tailed. So look, one-tailed, alpha is, what was alpha? 0.05, right? Oops, sorry. One-tailed, alpha is 0.05. One-tailed, alpha is 0.05, all the way down. 1.645, or you can say 1.65. 1.65 is our critical value. That's the answer to the question. Critical value, 1.65. Now, when we get our test value, when we use all this to determine our test value, right? If our test value is greater than 1.65, reject the null hypothesis. If it's less than 1.65, don't. Okay, so again, the critical value, the answer to the question is 1.65. For 23, a recent survey of gasoline prices indicated that the national average, the whole national average, was $4.98 of a dollar per gallon. Whatever. The Dallas Automobile Club claimed that gasoline in Texas was significantly lower than the national average. So we know null is going to be the population mean is actually that. And the alternative is that population mean is really less than, significantly lower than. Okay. A survey covering 10 different suburbs. I want you to get used to pulling this information out, because when you do the entire process, you'll need all this information. The survey covering 10 suburbs found the average price of that sample to be $3 and a little over 92 cents per gallon. Population standard deviation of a little over 5 cents. What should be the critical value if alpha is 0.01? So 2, let's draw my picture. I always draw my picture in step 2 if I'm using the traditional method. We're talking about significantly lower. Still a one-tailed test. Alpha is 0.01. One-tailed, alpha is 0.01. One-tailed, alpha is 0.01. That critical value, 2.326. Let's say 2.33. Let's round. Sometimes the book rounds, sometimes it doesn't. So 2.33. But this is less than my mean, so negative 2.33. That's my critical value. And when we calculate our test value, if it's less than negative 2.33, reject the null hypothesis. If not, if it's greater than, do not reject the null hypothesis.